All right, so let's start our conversation about what is density. It's a word a lot of us are familiar with. We've used it in different ways. Something is super dense, right? We hear people talk about that and they're like, oh yeah, salad dressing, it's separating because of density. So it's a word we like know, right? So let's get the chemistry of it going. So density is really a word that we're using to describe like how much space an object or a substance is going to take up, right? So that's its volume in relation to the amount of matter in that object or substance, its mass. And so another way we talk about this is that we are talking about mass per unit volume. And so let's get into this, right? So here we go. So these are our guiding thoughts that are going to lead us through our density unit, thinking about, again, how does a change in mass or volume, how does that affect density if density is based off of those two things? How can we use density to figure out if things are floating or sinking, right? Or again, that salad dressing, you're seeing that separation. Okay, why is that happening? Why in a puddle do you see that like sheen on the top? Like what's going on? And then also, then we're going to get into looking at how density helps us determine what substance we might be dealing with, because each substance has its own unique density. And so if we can figure out a density, we can then use that to identify a substance. So at its very simplest level, when we think about density, a good thing to reference is compactness. So when you look at the two cubes in this example, cube A, you see a certain number of dots and there's a certain amount spread apart, okay? And so cube B, you see them more spread apart. So cube A and cube B, you can tell have the same volume, right? They're the same size. But when you look at the amount of matter in them, the amount of mass, well, that's different. And so when we talk about compactness of the molecules, cube A is definitely more compact than cube B. And so when we go with that, we would say that cube A is more dense. Let's look at some more examples. So here we have the orange example and the turquoise example. And again, referencing compactness. So I want you to think about the following two questions. Okay, so right, again, compactness, how close those mass units are per unit volume is telling us how dense something is. And so now what I'd like for you guys to do is to take some time and draw from your old notes and fill in the information that we need here. These terms are going to be really important as we go through and continue to study density. So as you get to this portion of your notes, go ahead and pause the Edpuzzle and go back and fill these in. You need to reference your old notes to do so. Awesome. So when you did that, hopefully your definitions are similar to this, probably a little more thoughtful. These are kind of just quick thoughts, right? So mass, we're talking about stuff, volume, space, and then density, we are relating that stuff to its space, right? Again, that compactness of our stuff in our space, those dots in the squares. And so we actually use, when we're talking about density, we say that density is equivalent to the mass per unit volume, right? And so we can use that mathematically, in fact, and simply say that density equals mass over volume. Okay, and so that's the equation that we're going to use as we go through and solve these density problems. So what you have here is this magic square that we call the density triangle. So the density triangle is an awesome way to remember this density equation, and it also will help you with the algebra if you know density and you need mass, or if you know the volume and the density, right, you're solving for mass. If you know the volume and the mass, you're solving for density. If you know mass and density, then you're solving for volume. And so this triangle is really great. So the way it works is if you were to cover up one of the shapes, okay, so, or one of the letters rather. So if I covered up density and we don't see it because I'm solving for density, then you see that mass is over volume. And that is the equation for density. If we covered up mass, for example, So mass is what I'm solving for. Well, then density times volume is the equation that we will use. And if we covered up volume, because that was what I was solving for, it equals mass over density. So again, cover up what you are solving for, m over v, d times v, m over d, to get the easy way to do the algebra. So let's take a look at a problem. All right, so for this first problem, it says, osmium is a very dense metal. What is the density in grams per centimeter cubed if 50 grams of the metal occupies a volume of 2.23? So to set this up, we are going to use the information provided in the question. So it has a density is what we're solving for. The mass is 50 grams. So it's always a good idea to list what you know from that question. The volume was 2.22 centimeters cubed. And then our density is our unknown. So to set up this problem, we know that density equals mass over volume. So that's going to be our 50.0 grams over our 2.22 centimeters cubed. Now notice our units, I kept them in the problem because I want to have units in my final answer. Density is always going to have a unit. So when I plug this into my calculator, I'm going to get 22.5. Now, in terms of the units, it's going to stay what you saw. I had grams over centimeters cubed, and those don't cancel. So it's grams per centimeter cubed. Okay? And so again, list what you know first. Okay? That's always the key to starting these problems. Always list. All right? Then over here, we had our equation. Then here, we plugged in the numbers, and then we solved. All right, now it's your turn. Okay, so this is just a problem I wanted you to have in your notes because I think it's really important to understand the sinking piece. Like, right, why do some things sink? Why do some things float? And so as you look here at this problem, so the question reads, a block of aluminum occupies a volume of 15.0 milliliters. It has a mass of 40.5. What is its density? And will it float or sink in water? So one thing to note is that the density of water is 1. Okay? And so if something, it has a greater density than that or a less density than that, we need to think about, okay, well, is that thing floating or not? Okay? And so as we think to that, let's take a second before we fully analyze this problem to think about floating. All right, so here we go. I have a ping pong ball. I am telling you that the density of that ping pong ball is 0.0840 grams per centimeter cubed. Again, we know that the density of water is 1. And so, because the density of our ping pong ball is less than the density of the water, the ping pong ball is going to float. Okay, so again, I'm giving you these numbers so you can see them exactly the way they are. But let's say instead of a ping pong ball, we had a marble. Now I'm telling you that the density of the green marble that I'm using is 2.5 grams per centimeter cubed. So when I put that marble into the bowl of water, the marble is going to sink. And again, that is because the density of the marble is greater than the density of the water. So let's take back to this question. Again, I want to know if my aluminum is going to float or sink. But in order to answer this question, I need to do the math and figure out the density. So, given that we know the mass and the volume, I use my density triangle that is telling me If I need density, I'm going to cover it up, right? Remember that? So I cover up my D, and now I know that it's mass divided by volume. I plug those numbers in, and I get 2.7 grams per milliliter is the density of my aluminum. So if I were to put that substance in water, it would definitely sink. So now you guys are going to take some time and do some problems on your own. So take your time, work through these problems, and you'll see that the correct answers are provided for you.